everyone, my name is Varun from Mathematics Department. So today I am going to discuss the UT paper which is based on the entire calculus part. So we'll start with 41st question. Minimum value of y is equals to f of x, where f of x is equals to x power 4 plus x square plus 1 by x square minus x plus 1, where x belongs to r is alpha by beta in lowest form, then integral beta pi by 2 to alpha pi by 2 sin square x by 7 dx is equals to lambda. Then is asking the integer part. Now it's quite obvious, this function is nothing but x square plus x plus 1. The range of this one is 3 by 4 to infinity. So if the range from this one is 3 by 4 to infinity, and this minimum value is attained at minus 1 by 2. From minus 1 by 2 to infinity, x square plus x plus 1 will be something like this. This is the value at minus 1 by 2. So, minus 1 by 2 to infinity, the function will be always increased. X square plus x plus 1 attains the values from close 3 by 4 to infinity. Now he is asking f of again this part, that is f of x, where x belongs to 3 by 4 to infinity. So now as x belongs to 3 by 4 to infinity, the function will be always increasing. So there won't exist any maximum value, but there will be a minimum value which is nothing but f of 4 in this function f of x. I'll get f of 3 by 4 is 37 by 16. So 16 is beta and 37 is alpha. 1 by 7 into integral 16 pi by 2 to 37 pi by 2 sin square x by x dx. So how will we solve this part? Sin square x is nothing but 1 minus cos 2x by 2. Integral cos 2x from 16 pi by 2 to 37 pi by 2 dx part will be equal to 0. We are not bothered about this part. I am left over with this 1 by 2. So this 1 by 2 into 37 minus 16, 21 pi by 4. This must be 21 pi by 4. So this value will be nothing but finally 3 pi by 4. 3 pi by 4 integer part is nothing but 2. Is this clear? So this problem you come across many times. X power 4 plus x square plus 1 by x square minus x plus 1 is nothing but x square plus x plus 1. So we go to the next question. Question number 42. This is a time taking problem again. Number of real alpha for which integral alpha to alpha plus 1 e power x by x dx is equals to e plus 1 by 2. And alpha into alpha plus 1 is greater than 0. See, he is making it easy for you. He is just saying that alpha is either greater than 0 or less than minus 1. So keeping that in mind, we will try to solve it. And one more thing, whenever he is asking number of real alpha, one hint you need to get is you need not solve for alpha. You just have to identify the number of values of alpha. So the graph purpose may help you most of the time. So we will go for solving it. E power x by x function I will try to draw it first. F of x is equals to e power x by x. F dash of x is equals to x times of e power x minus e power x by x square. F dash of 1 is 0. So at x is equals to 1, the function attains minimum. In rest of the cases, here the function will be decreasing, and then again increasing. So this is the graph of e power x square. Now, for different values of alpha, I have to check what is the nature. Case 1. The f dash of 1 is equal to 0. And at 1, the functional value is e. If you take any alpha to alpha plus 1, this area will be always greater than this area. This area is nothing but e. So if this area is e, always integral alpha to alpha plus 1 f of x dx will be greater than e, which is greater than e plus 1 by 2. So if alpha is greater than 0, there won't be any solution. We can directly skip this part. But if alpha is less than 0, what are the cases? Obviously, alpha is less than minus 1 case. If alpha is less than minus 1, what will happen? You take alpha here and alpha plus 1 here, the area will be very less. But if you take alpha here and alpha plus 1 here, the area will keep on increasing. So, the area starts from 0 somewhere here and the area goes on increasing till it it attains some value. We can't say it is infinite. That is our task actually. Integral -1 to 0. Integral -1 minus to 0 minus e power x by x dx is the maximum value at which it can attain. So we'll just try to understand if this value is lesser than e plus 1 by 2 or greater than e plus 1 by 2. See, what I have done is, for this negative part, I took a point t comma e power t by t. So y minus e, I drew a tangent there and I wrote this point as a and this point as b. Y minus e power t by t by x minus t is equals to the slope, and I found out the y-intercept and x-intercept. A-intercept, x-intercept came out to be this one, y-intercept came out to be this one, and if you observe, this value will be tending to 0 as t tends to 0. So I'm just saying that -1 will be somewhere here, because this point tends to 0 as t tends to 0. So keeping that in mind, this is A and this is B. Area of triangle OA will be nothing but half times of OA into OB into OA. So this area, if we identify this area as limit t tends to 0, this area tends to 2. That means he's saying that this area is equals to 2 as t tends to 0. So if this area itself is equals to 2, integral -1 minus to 0 minus mod of e power x by x dx will be greater than 2. That implies there exists some negative alpha for which this value is equals to e plus 1 by 2. Because it starts at 0, it goes to a value that is -1 to 0, this area will be greater than 2. That means somewhere in between it will be equal to e plus 1 by 2. So there will be one negative value and no positive value, and hence the answer is 1. We'll go for 43rd question. Area traced by the points satisfying y square minus 4x is less than or equal to 0, a parabola, y square is greater than or equal to x square, pair of straight lines, and mod x is less than or equal to 2. Again, pair of straight lines, but we are not bothered about x equal to -2 part here. Is lambda square units and lambda is equal to 2. So we'll just try to draw the graph here. I'll zoom it a little bit. So this is the graph. This is y square is equals to 4x. This is y square is equals to 4x. This graph is y square is equals to 4x. This graph is y square is equals to x square. The points of intersection will be 4, 4 and 4, -4. And this is x is equals to 2. So saying it must be lesser than 2. It must be lying towards this boundary. That is, this region must be included and it must be lying inside the parabola. So this is the part which we have to find, the area, the shaded region. So I just founded the points of intersection there. This point is 2, 2. This point is 2, 2 root 2. This point is 2, -2. And this point is 2, -2 root 2. So what I'll do is, this region, that region area will be nothing but delta will be 2/3 of AB, 2/3 of the rectangle area, 2/3 of, or you can do it with direct integration also, 2/3 of 2 root 2 into 2, 2/3 of 4 root 2 into 2. This will be 16 root 2 by 3 minus this area, the blue part which I have drawn. That area will be nothing but half into 4 into 2, which is nothing but 4. So the overall area will be nothing but this part minus this area. I am getting it as 16 root 2 by 3 minus 4. If you find the integer part, you will get it as 3. We go for 44th question. A curve passing through 2, 3 and satisfying integral 0 to x t y of t dt. Here it looks like there is a function y, but this function is completely expressed in terms of t. This whole function is completely in terms of t. So you can directly apply Leibniz formula. Is equals to x square into again y of x, where x is greater than 0. Is xy equal to lambda, then lambda is equal. See, you need not solve the whole problem. Yes, 2 comma 3 you can substitute in this part, you'll get directly lambda is 6. But we'll go for the method again. I'll differentiate this function. If I differentiate this function, what will it be? Xy is equals to x square times of dy by dx plus x square derivative is 2x into 1. Dy by dx into x square is equals to minus xy. Now, he mentioned x is greater than 0, so I can divide it by this. I'll get this part. After this one, I can write it as x dy plus y dx is equals to 0, which implies d of xy is equals to 0, which implies xy is equals to 0. And then you substitute the integration constant. For getting the integration constant, you substitute this 2 comma 3, you'll get c is equals to 6. We'll go for the next question. Question number 45. Let f of x is equals to x cube plus x plus 1 and let g of x be its inverse function and equation of the tangent to y is equals to g of x at x is equals to 3 is ax plus by plus 1 is equals to 2. Then a minus b is equal to. So in order to get a and b unique, he gave the constant as 1. So we have to find out. He's asking, he gave g of f of x is equals to x. G is its inverse function. And is asking g dash of 3. So I have to identify the value of x for which f of x is equals to 3. So value of x, if x is equals to 1, f of x will be equal to 3. And from this function I can write g dash of f of x into f dash of x equal to 1. So this is 1 by f dash of x. So what is g dash of f of 1? 1 by f dash of 1. F of 1 is nothing but 3. So g dash of 3 is nothing but 1 by f dash of 1. F dash of 1 is nothing but, again, 3x square plus 1. So 3 times of 1 square plus 1. This will be 1 by 4. So I know the slope. I know a point on it as g of 3. What is g of 3? 1. Because g of f of 1 is equals to 1. So y minus 1 by x minus 3 is equals to 1 by 4 is the tangent equation. You have to be careful. He's asking tangent or normal. So look at it, he's asking the tangent equation. So this will be the equation of tangent. You can simplify it and obtain the values of a and b. We go for 46th question. Let f of x is equals to x square plus x into a constant plus some constant. G of x equal to x square plus x into a constant plus another constant. Again, we need not solve complete f of x and g of x, but you just look at the option. He's asking g double dash of x and f double dash of x. If you find out f double dash of x for this one, what will it be? F dash of x is 2x plus g dash of x. F double dash of x is simply 2. Identical for all values of x. Similarly, this will also be equal to g double dash of x for all values. So simply this value is 2, this value is 2, the sum will be 4. 47th question. The value of integral 0 to 1 e minus 1 into root over ln of 1 plus e minus 1 into x plus e power x square into dx is equals to lambda. Then integer part of lambda is equals to, where integer part denotes here. See, whenever the function looks complicated, obviously there will be some. Do not panic here, because e power x square is non-integral. This function also looks complicated. There will be some trick. So one thing which we can observe is e minus 1 dx is coming. When we differentiate this part, we'll get e minus 1 dx. So the hint is to take this one as t. ln of 1 plus e minus 1. I'll try to eliminate this root part. Whenever I have 1 by 3 power, 1 by 3 power, 1 by 6, I'll try to eliminate the radical sign. So I'll take this part as t square instead of simply taking it as t. I'll differentiate this part. What will I get? 2t times of dt by dx is equals to 1 by this part into derivative of this will be e minus 1. So this function I'll substitute it here back again in this one. I'm taking only this part. I'm eliminating e power x square. I'm only trying to evaluate this value, first value. Integral 0 to 1 e minus 1 into root over ln of 1 plus e minus 1 into x dx will be nothing but integral 0 to 1 ln of 1 plus e minus 1 into x is nothing but t square. So root over t square will be t and minus 1 into dx. E minus 1 into dx would be nothing but 2t dt into this part is nothing but again e power t square. So I just substituted this value here. Integral 0 to 1 2t square into e power t square dt I am getting. For this I'll try to use bypass. I'll split this part. 2t square I'll write it as 2t into t. So e power t square into 2t integral is nothing but e power of t square into t, limits from 0 to 1, minus integral 0 to 1 e power t square into derivative of t. Derivative of t is nothing but 1. So this part and this part gets cancelled, and overall I'll get only this value, which is nothing but e minus 0. So the answer will be, and the integer part for it will be 2. We go for the next question, question number 48. For x is greater than minus 1, log, let f of x is equals to integral 0 to pi by 4 log of 1 plus x tan z. You can't directly apply Leibniz here. There are two variables, x and z. So you can't directly differentiate f dash of x or something like that. But anyway, these are finite values. Log of 1 plus x tan z dz, then the value of f of 1 by 2 minus f of 1 by 3 equals to pi by 8 log k, then is asking integer part of k. So again, you just try to use this part. You don't go for simply solving this one, because again if you use a plus b minus x, I don't think it can be reduced. We'll just try to use this part. F of x, he gave it as integral 0 to pi by 4 log of 1 plus x tan z dz. F of 1 by 2 minus f of 1 by 3, substitute x is equals to half and x is equals to 1 by 3 here. What will you get? Integral 0 to pi by 4 log of 1 plus tan z by 2 minus integral 0 to pi by 4 log of 1 plus tan z by 3, which is nothing but integral 0 to pi by 4 2 plus tan z by 3 plus tan z. I'll be left over with a constant 3 by 2 here. This 3 and this 2. So that part I'm writing it here, log of 3 by 2. So I'm splitting it into two intervals. Whatever value after evaluate, I dash, I'm writing it as I plus this constant. So now I'm going through this I part. I is nothing but integral 0 to pi log of 2 plus tan z by 3 plus tan z. Now we can use a plus b minus x plus it. I is this part. I'll use a plus b minus x. In the place of z, I'll substitute pi by 4 plus 0 minus z. Pi by 4 minus z, I'll substitute in the place of z. I is equals to integral 0 to pi by 4 log of 2 plus 1 minus tan z by 1 plus tan z by 3 plus 1 minus tan z by 1 plus tan z dz. I'll add the two quantities. First of all, what will this result be? Log of, you can understand here, 2 plus 2 tan z plus 1 minus tan z. I'll get 3 plus tan z in the numerator. And this part 3 plus 1 4, 3 tan z minus tan z, 2 tan z. So again, this part is nothing but, if I add these two, I and I, 2i will be nothing but integral 0 to pi by 4 log of half dz. The 2 which is there in the denominator will come here. The rest part gets cancelled, this one and this one. Because this is of the form log of a by b and this is of the form log of b by 2a. So log 1 by 2 tz. I'll simplify it. I from this one. I is pi by 8 log 1 by 2. This other value which is left over, I'll add it here. Plus pi by 8, I'm multiplying by 2 in the numerator and denominator. Pi by 8 log of 9 by 4. So I dash will be nothing but pi by 8 log of 9 by 8. So the value of k is 9 by 8. And integer part of it is 1.